Hello, hello, hello. We will be starting in 1 or 2 minutes, so if y'all could please sit down soon, that would be awesome. Hello. Oh, yeah. Good to see you. Good to meet you. Likewise. It should be fun, yeah. Hopefully. Thank you. All right. Wow, that actually worked. I'm amazed. Thanks, everyone. Yeah, so I'm here to talk about Whimsy, which is always a fun subject. if any of you have like feedback about this talk, that would be super appreciated to come pester me afterwards. I'll be giving the same talk in about a month at React Europe in Paris. And so this is a great opportunity for me to find the problems with it. With that said, let's do it. I'm Josh. I work for Khan Academy. We're currently hiring senior engineers, so come talk to me if that interests you. And I wish the internet was more fun. So I started using the internet in the mid-90s. This is what it looked like. You discovered sites through web rings, and everything was perpetually under construction. Remember Ask Jeeves, anybody? I remember that you'd ask it a question, and you would never actually get a useful answer, but it nevertheless was this charming, delightful experience. We had a single tool for animation, and that was the animated GIF. This is fish, I think, somehow. Everyone would just do this, which I always thought was fun. This is actually McDonald's first website in 1997. There's a McWorld, McDonald's Japan, and if you look closely, there's a little man who pops out behind the arches to give it a polish. This is McDonald's website today. And I think it's hard to argue that this website isn't better. Like, you can see the food. You can figure out where the location is. You can even order delivery, which I tried recently, and it was thoroughly unsettling. You don't want to get McDonald's delivered to your house. But I feel like for all of the good of this website, it's everything that it needs to be and nothing more, right? There's no little man brushing off the arches. There's nothing fun about it. There's nothing whimsical about it. So I'm going to be talking about Whimsy. This is the definition for it that I made up, an unexpected flourish that sparks joy. And I like this definition because it's like really, it focuses on the fact that it's something extra to the experience. It's not critical to the experience, and yet it really helps make the experience better. So this is a broad definition, and because of that, it's pretty easy to find examples. So this is from a site called Unsplash, where I used to work, and this is their error page. So you have a guy that can't get the ketchup out, and then, oh no. Every time you get an error page, it's a different GIF. So this one's my favorite. Cat can't get up. I could spend quite a bit of time talking about error pages and the cute things people do for them. But today I'd like to focus on interaction and animation. And the reason for that, I mean, aside from this being a React talk and React not being a useful tool for animated GIFs, is that I think this is like the area most ripe for innovation, where there's really not that much done in this area. Well, I mean, there is, but there's plenty more room, and it has such a core effect on the user experience because the difference between like a document that you can print out and like a rich dynamic web application is interaction and animation, and we should be leveraging that. So let's look at an example. So Khan Academy, for those who don't know, is a platform for learning. We do math and science and other things. And one of the ways people learn is by completing exercises. And we wanted to add this confetti in the background so that if you get every exercise in a series correct, 7 out of 7 in this case, we wanted to rain confetti down on the screen. And there's like, the fun thing about this was just how much was open to interpretation, right? This is a static mockup, but presumably it would be animated. And so there's a number of ways you could do this, right? Like perhaps the simplest would be to ask for a pattern of just the confetti tile and then tile that for a div the size of your window, and then just translate that down the screen. But that wouldn't be very fun. Thankfully, we already had a confetti rendering engine that someone else built. And so I was able to like take that and add a couple things to it and make it support these particles. And we wound up with something like this, which I think is pretty fun, and people seem to like it. This is like, so one thing I find super helpful when building things like this is to have a way to quickly iterate and see what it does. So these are like the parameters, the props that this component takes. So see if I add spin, then there's this like 2D spin as things fall. If I add twist, actually I'm gonna make it a bit bigger too, that would help. If I add twist, they like flip in 3D space, and there's actually, it might be hard to see, but they have a back face that's a different color or a darker color. And you can add gravity, and let's try to make this look good. So I do that, we get like, hey, it's confetti, it's cool. That should not be there, go up. How many of y'all have worked, or let's start with how many, if I get a show of hands, how many people who know what Canvas is? Canvas is the, cool, a lot of people. How many people have worked with it? Still quite a few people, awesome. How many people have worked with it with React? Cool, not as many. So there's an abstraction that I like to use, which is just a Canvas component. And it does kind of a lot of the finicky canvas work that I'm sure a lot of you have experienced, but it like packages it nicely in this little thing. So let's look at it. We have some props. We need a width and a height, same as a regular canvas would need. And we have a draw function. And I like to think of this as like a render prop, except it renders to canvas instead of to DOM. If we jump down to the render method all the way down, you'll see that we're not actually doing that much. We're rendering a canvas, and we're capturing a reference to it so that we can access it later on this.canvas. If I scroll up to our component.didMount method, you'll see that the first thing that we do is we get a context. Here we're choosing a 2D context, but you could also do WebGL, although really that canvas for confetti is fine. Then we call this scale method, which we'll look at momentarily. And then we call this.props.draw, which is our render prop. Similarly, on update, we invoke the same draw function. This scale function is kind of what I think is cool about this, in that this is just code to scale for high DPI displays, like Retina displays, which is like not fun, but necessary so that you can get sharp canvases on Retina displays without having to learn a whole different coordinate system. So yeah, that's pretty well like a nice simple component that allows you to build other things on top of it. So the way this works is, you'll see I have a width and a height, and I think this works. If I change it, it does. So I can, let's see. If I change this to 10, you'll see it moves. Too big. So I'm essentially just giving it a color and adding a rectangle. And like the cool thing is that this is just straight canvas. So what's neat is that whenever this canvas demo component renders, it redraws. So what if we wanted to animate this? You'll see that I have a bit more code, but fundamentally it's very similar looking. I wonder if this actually goes in real time. It's close enough. So you'll see that we have this draw method, which is almost exactly the same. The only difference is that we're specifying an X and a Y instead of just giving it values. And so if I click on this, you'll see that it moves. And the reason it does that is that I have this on-click handler for this.start animation. If I scroll up to that, you'll see that the first thing to do is we stop the animation. That way I can click on it multiple times, and it doesn't like cause a bundle up of these events. And then I have, I set the initial state. I wonder if I can, yeah, let's make this bigger. Cool, that's better. I have this, I set the initial state, and then as the callback, I provide this.tick. So this.tick, it uses window.requestAnimationFrame, which is just like a nice way to synchronize events, have them be called as often as the browser can, ideally at 60 frames a second. And every time it runs, we're incrementing the X value and the Y value by 1, and then we're setting the tick as the callback. So like pseudo-recursively, we're calling this whenever the animation, and that's how you get this effect of it redrawing itself like at every new position, and you get that like nice simulation of animation. And so like that's pretty well how the confetti works. There's like a fair bit of subtlety, but, or not even subtlety, just like finicky details that are probably not interesting enough to go into. So I'm gonna go through this code, but I'm gonna like snip some stuff out. You'll recognize the scissors for when things are omitted. So for props, we have a width and a height, which is a pretty common thing when working with Canvas, that I just always funnel this down. Then I have all the props that you saw in that little demo before with the confetti, with a couple others, like the emit duration is just how long you want it to emit over. And then I have this make it rain on prop. One of the challenges is always like figuring out how to like, because React is state-based, and in this case, we want it to be like event-based. Like when I click on it, I want it to do something. And so if I just set the state to raining, then it wouldn't let me click multiple times. So we'll see how I dealt with that. I have this make it rain on that I only bothered to implement click here so that whenever you click, it should rain more confetti. But you can imagine doing it on mount or on hover or on when a certain prop changes or whatever. I have sensible default props, and then the confetti component manages the particles in state. If I jump way down to our render method, you'll see that, this little thing, I'm going to talk about this more later, but I'm going to ignore it for now. And then you'll see we use our canvas component. So there's kind of like two functions here that are important. One is that we have this.draw, which is passed as our draw method. And then I have this.generate particles. If we look at this.draw, you'll see that it's actually not that different from that like pink square demo. So the first thing I do is I clear the rectangle. I also pluck the, I wonder if this will go through it. Yeah, so I pluck the particles out of state, I clear the rectangle, and then I just iterate through all the particles in state. And I do all of the like transformations necessary so that the particle that I'm iterating through generates at the right spot with the right rotate and the right scale and all of that. and then I just draw image. The way the confetti is actually stored is as SVGs. That way designers can just pass it to me. And there's this cool, like you can just paint an SVG into a canvas, which kind of blew my mind when I found out. And then I just reset this way all of the translate and rotate and scale are reset for the next particle as we go through this iteration. Then the other thing we saw is that on click, right, with the make it rain, it generates particles. This is how particles get added. While loops, who remembers while loops? I would probably use like a range function and map through them, but I wanted this to be like vanilla JavaScript. So here we are. So we have a counter variable I, we have an array of particles that we're gonna push into, and then we iterate from 0 to the number of particles we wanna generate. There's a bunch of code that was snipped out here, which is like giving it a random scale and a random spin based on the like acceptable parameters that you provided. And then we take that new particle, we push it to the array, and then we increment our counter. So that by the end of this, we have an array of new particles, and then we can mix those particles into the existing particles, which is how you get that effect of when you click, it just keeps adding new particles. So if this was all of the code that we had, you could still click on it, and you would still get confetti, but it would just like float at its initial position. There's nothing actually like animating it. And for that, we look to our component.update method. So essentially what we're doing is that when you click on it, the generate particles function runs. And so then after it updates, and so that generate particle pushes to the state, on every update we check to see, did we have no particles, and do we now have particles? So if we go from 0 to more than 0, we know that like, hey, it's time to start animating. So we call this .tick. Our tick function, again, pretty similarly to the pink box. First we check to see if we're out of particles, so that once they fall off the screen, we remove them from this list, and if they're gone, then we don't need, if all of them are gone, we don't need to keep going. And then we schedule an animation frame so that, let's go through it. We figure out the next position for every particle, and then we set our state with that particle and queue this .tick again. Okay, calculate next position for particles. This is again like pretty snipped because a lot of it is just taking the like position of each particle and the amount of time that passed since we created it and working out where it needs to be. So there's a bit of trigonometry there to figure out the exact, like, given its initial angle, where it ought to be, given how much time has passed since that particle was born. And because we now know the new particle position, if we can tell that it's off the screen, we can just return null, and then we filter that out. So that at the end of this method, we have a new list of particles, not including any that have fallen off the screen. And that's pretty well it. That works because when the component updates, we start this animation loop, and it will just keep animating frame by frame until all the confetti is gone. And it works well. You can keep adding confetti to it. Why not SVG? Why did I do this in Canvas? I actually prefer SVG for most things. The reason that I chose Canvas for this is that you can really shove a lot more particles in it before you run into performance problems. SVG is still just DOM, and so every time you have to move something in the DOM, there's a cost to that. You have to move 50 things. It can get kind of hairy. Canvas, I mean, it still has the limitation of having to iterate through more things, but it's like, it scales far more generously. Something I kind of anticipated is that, like, this is fun and all, but I work at Serious Company. We wouldn't add confetti to our app, to which I would say Facebook did it. And I think I've seen like a few examples of this, right? Like I think Medium had this thing for authors where at the end of the year, there's like this summary they send you that has confetti on it. There's a surprising amount of use cases for it. But I think I still I take that point because really like it is not something that every app needs to have. And so let's look at something more mundane. Let's look at an email client. Go do a demo, Josh. Okay. So here I have an imagined email client. You'll see that I can switch between things. This is actually an email that Ken Wheeler sent me when I asked him for a fake email, which is fun. The first thing is that the modal for composing an email will expand from the part that you click it so that the reply is different. And let's reply, let's say like, yeah, okay. When I click send, the letter folds itself up and it shoots towards the outbox, and then we get a little notification. The other cute thing is that like, if I decide, no, I don't actually want to do that, I can clear it and it shakes itself away, which is kind of fun. Let's go back to the talk. Okay, so the first thing, and I kind of mentioned this already, is that, actually no, I didn't. So the reason I think that these animations are neat, aside from just being whimsical and fun, is that they're action driven. So like what's being shown here are 3 different ways that the modal closes. Like these look fancy, but they're really just the modal's closing. So the first one, let's wait for it to get there. That one's like you dismiss it. So you click away and it goes away. That's saving a draft. So it folds itself up with a white screen. And this is actually sending it where you get the cute little border. And so like this is not how we typically do things in React, because often in React, we're animating based on state. Like you have an isOpen like state prop in your, like your modal has an isOpen state. And when that state changes from true to false, you like fade in or out depending on that. And that works, but it doesn't allow you the freedom to like choose a different animation depending on the action that's happening. This subject was written about in a lot more detail by Tobias Island. I highly recommend those who are interested check out his blog post because it's pretty cool. I also stole the idea of an email client from his blog post. The other thing that's cool about this is the fact that it transports between nodes. So this is the part that I kind of mentioned, which is that when you open an email, you'll see that it opens the modal from that. But when you send it, the actual like folded up letter shoots itself towards a destination node. Why is it making sound? Good. Yeah, so that's the cool thing. And then the final is this like folding animation. So here I've slowed it way down so we can look at it in more detail, which was like a fair bit of fun. Now, this is something I've showed to a few people. And the reaction I often get is that like, well, that's fun, but are you really going to make users sit through this like obnoxious animation when I'm like a serious business user and I have 70 emails to send? And like, why won't it just close the stupid modal and let me go back to my business? To which I would say like, no, of course not. One thing that we don't really do a lot is write self-disabling animations. So the analogy I like to have about this is that like, let's say I have the funniest joke anyone's ever heard. It wouldn't be funny the 70th time that you hear it, but the solution is not to just never tell jokes, right? Like stop telling the joke after the first couple times. So it's not a pattern that I've seen a lot, but like, why don't we have whimsical animations at first that can like gradually degrade? And then also like power users or even folks with vestibular disorders, which we'll talk about in a bit, can disable that animation if they don't want to deal with it. And like the cool thing about this is that so with this example here, let's go back. I guess the folding animation is part of it. It's like built-in onboarding, right? Like how many times has it happened where you're using some new product, you save a draft, and then you have no idea where your drafts are? And like maybe it was covered when you signed up in one of those onboarding tooltip things that everyone just clicks out of right away. But this actually shows you like, hey, this is where your thing is going. If you need it, it's over there. So not something you need to have every time, but something very useful the first couple times. Okay, let's look at how we folded it. So somewhat meta-ish, this is a demo of the demo, which is that it's what appears to be a single DOM node, but it's actually 3 DOM nodes. And the way that this works is that each DOM node has an image, and each image is the full size, but it sits in a container that has its overflow hidden. So this like mouse hover effect is just me removing overflow hidden. So you'll see that like this one, for example, it has the content shifted down, and then it has overflow hidden and it's cropped with its height. And when you do that, it turns out to be really easy to have this folding animation because then it's just about CSS rotation. So that I expected to be kind of tricky, but it wound up not being so bad. Let's look at how that works. And again, scissors, abridged version. So we have a prop is folded, and we use that to figure out whether or not it should be folded at the current moment. Front is kind of like children. It's like what actually gets rendered. I named it front because there's also a back. So if you want to render like the cute little airmail envelope, you have a place for that. And then a duration is just how long it takes to fold. And then we have a default prop for that duration. Again, shooting way down to the render. We always render the original. And if the prop is folded as true, we also render the folded copy. The render original, you'll notice that like most of what it does is just return this .props.front, which again is kind of like the children. But we wrap it in a div, and we do that for 2 reasons. One is so that we can capture a reference to that node that we will need for the folding. And the other is that we apply style to it so that when is folded is true, we can hide it. Meanwhile, the folded copy uses that node after it's mounted, and we get a bounding client rect, which is essentially like, where is this item in the viewport? And we do that so that our folded copy can sit right above the original copy, right? So the top, left, and width and height are applied so that it's the same size and the same place. Then we have this like pretty gross chunk of markup. I'm using styled components here, which is like top fold is just a styled component. That's kind of the wrapping node. So it's the one that actually rotates. Then we have this hide overflow, which just hides all of its children. It takes up the full size of top fold and then cuts off everything below it. And below it, we have top fold contents. And the way this works is that because we captured a reference to this .node, we can take that node's outer HTML and like inject it into here. So that's how we get the foldable contents, is just that by copying the original node's content. And then I should have gone through that. And then we do kind of the same thing for the middle fold and the same thing for the bottom fold. And then there's a whole, all right, we're back to there. And then there's this like whole mess of CSS that we're not going to go through because it's very long. But this is kind of why I feel like React is awesome, because this is primarily a CSS effect, but it's a lot of CSS. And it would not be fun if whenever you wanted to make something foldable, you had to like port over all of those things, because it's not just a couple classes, it's this whole DOM structure. But because it's React, we can abstract all that into a component with like a pretty nice API. So here's what it actually looks like to use it. This is like in our email example, it's kind of like the modal, but it could be whatever. It has some state, which is a Boolean of sent. There's a way to set that sent to true, which is how it gets folded up. And then it's just this. Like, it's really not too bad. There's an is folded, which we're just passing along the state. The children, AKA front, is this letter. And like, so none of the code is concerned with the folding, right? All you're concerned about is sending the letter, and the folding just happens as like a nice happenstance because this sent variable changes. So that's pretty cool. Let's look at how we do that transporting. So this is like the React Storybook version of this, just to show like the behavior that I want, which is that you click on a node, it expands from that. And when you click on the same node, it retracts. But if you click on a different node, it like teleports, or slowly teleports in slow motion towards where you're going, if that makes sense. There's kind of a couple pieces to this. So the first is that we need to know where all the nodes are on the page, right? So for this to work, we have to know where these 4 buttons are. And using the new React 16 context API, there's kind of like a nice way to do this, which is we create a new context. How many people have used the new context API, are familiar with it? Cool, not a ton. So how many people have used the old context API? Okay, let's go over it quickly. So context is essentially global state for your React components. You are discouraged from using it, especially using the old API, because it's very easy to like make the whole nice part of prop funneling in React void by just like having this global state in your whole tree that you can bypass props with. But yet it's super useful. In fact, it's what React Router and Redux all use behind the scenes to be able to facilitate pulling state out of Redux and all of that. React 16 introduces like a new wrapper around it that allows you to access your context through special connected components that just pass that context down as props. Thus, you save the whole, like you can always be sure that the components you write are only changing when their props or their state changes. There's no magical context, so that's screwing up the whole flow. So this is a way to do that. We write a new node provider component. It's going to manage all of the DOM nodes on the page. So it has a map of nodes. And then it has this ref capturer function, which essentially just says, give me a new node, give it an ID, and then I'm going to pass that on to our current state, merging it in. So we render this provider, which if anyone's used Redux, it's very similar to the Redux provider. And its value is just that whole state object. It might look a little funny that we have a function in state. This turns out just to be an optimization, because otherwise, this is going to re-render whenever the component re-renders, because it's like a new function. This way, the function itself never changes. And then we export a consumer, which we'll go to the next slide because it'll hopefully be illustrative. So we have our app. Similar to Redux, we have this node provider, which we just wrap our whole app with. That makes the context available to everywhere in the tree. You can imagine that we have this inbox heading. So we have this consumer. And the first thing that we need is to pull this inbox heading node into that provider state. So we use the ref capture function. So we're just passing along a function to the h4 ref. And that means that anywhere else in our app, we can use the node consumer, which is handed this list of nodes, and we can access nodes.inboxHeading. So presumably in that other demo, we'd have 4 different boxes. And at a given point in our app, we'd have access to all 4 of them. So we could do the calculations needed to like move stuff around. This is an example of how the transport works. Sadly, I will not be going through the transport code, only because it's like fairly long, but I'm hoping that the high-level concepts of it are pretty easily transmitted. So I drew some boxes around stuff here. So you'll see that we have 2 nodes. We have our from node, which is the compose button in the top right, and the to node, which is our outbox. And then our child goes from one place to the other. So it starts with this like open modal in yellow. And then we know that it closes by going to the little green dot, the child end. So there's 2 things that happen. One is that it moves across the screen, and the other is that it shrinks to be 0 pixels in size. And so you can imagine, if we know where both of those nodes are, and we know where our child is, this is really just about getting the delta between those two things and applying a style. I used React Motion in it to give it like a nice springy effect, but you could just do a simple CSS transition. The way that this would get used, so here we have our compose email modal. It has a status of presumably either open or closed. You can imagine all like the typical modal stuff to open and close it. And then we have this node consumer. So like before, this is presumably we've captured these nodes somewhere else, and now we have access to compose button and outbox heading. And now we have this transport component. We pass the status along to it, which should either be open or closed. We give it a from node and a to node, and then when the status changes, it knows like, oh, the status went from open to closed. That means that I have to go from the from node to the to node. And if those nodes are different, then it knows to like shrink itself into it. And if it's the same, it knows to retract itself. And again, this is kind of cool because like this compose email modal, presumably the code that you would write in an app, if you were depending on this as a dependency, or even if you've written it yourself, you don't have to worry about the whole transport logic. You just give it the nodes that it needs, and that's kind of it. And actually, looking at it now, I'm realizing that I forgot to provide the children for it. The children for it would be like the compose email modal contents, so the thing that you want to transport. So just pretend that's there. All right, in conclusion, do anyone have questions along this? I meant to ask that and totally forgot, but hopefully, well, we can do that. I have a couple more slides, then I can take questions. What's exciting to me about this is that there's a ton of unexplored territory. So like, for example, this is a circle, but it's wobbly. I call this a wibbly wobbly circle. Because if you look at it, like, I don't know how, yeah, it's kind of obvious. It's like a bubble moving through space. As far as I know, there is no React component to wrap your children in a border that does this. But that, like, there's a million React animation libraries, but they all just are layers around CSS animations. None of them do like funky stuff like this. And there's no reason they couldn't. So there's a lot of unexplored space. And the future is like really exciting. And I don't even know all the cool things that are coming along, but a couple things that I've heard rumors about, or not even rumors, but seen things come around. This is the CSS Paint API, also known as Houdini. This is like the material design ripple effect. CSS Paint is this really neat thing that gives you a canvas-like API that you can use in CSS as a background. So like all of this could be a single CSS prop based on a workload that someone else writes. And it's really cool because once browsers support this property, you'll be able to polyfill any other CSS using it, or not any other, but like you could add stuff like this just with CSS, even for browsers that don't support some of the effects that you'd use in that effect, as long as they support CSS Paint. So that's cool. The other thing, so this is on its face a fairly uninteresting demo, but the cool thing about it is it's rendering using Firefox's new engine that they're building, actively working on. The thing that's cool about this is that this is 600 divs, and they're being positioned using top and left, and they're being sized with width and height. So like if anyone's done animations, like these are like the golden rule is not to touch those properties. And so you wind up having to do everything with opacity and transform, which is like pretty limiting. This is just like width and height and top and left. And it's running at 60 frames a second. So it's pretty cool. And it'll really like accordion effects, right? You click on a thing and it expands open. There's no nice way to do that without animating height because the height changes. So we'll be able to do cool things soon. One like important thing that I want to touch on is that I got about halfway through making this talk and I realized that like, boy, what am I doing? Like this is all really fun, but our internet is broken for a lot of people already. And this is not helpful for them, right? Like screen readers don't benefit from confetti. And so I think it's important that before we focus on all this fun stuff, we make sure that our site is actually usable for the people that want to use it. And at the very least, we should not be making the site harder to use for people. So the vestibular system is like the inner ear and the part of the brain that deals with balance. And if you have a vestibular disorder, like if you're prone to vertigo, confetti on the screen can actually make you motion sick. So that's not nice, right? We don't want to do that. There's a CSS media query called prefers reduced motion. I alluded to this earlier. It's a CSS query, or sorry, a CSS media query. So you typically would use it just to apply styles on and off. Confetti is a canvas, so you can't do that, but you can access the media query through JavaScript. And then you could presumably just bail early. The sad news about this is that it is only supported in Safari and iOS Safari. It is not anywhere near being ready to use in other browsers. At Khan Academy, what we did is we have a user setting by the same name, and then we check for either of those properties. So like if the user ticked the box, or if their browser is set up this way, we don't show the confetti. But yeah, getting back to animation and interaction, it's exciting because there's a bunch of like unsolved problems, and they're not unsolvable. Like I remember when I started doing like web programming years ago, someone told me that the most exciting stuff to work on is the stuff that no one's done yet. And I thought like, well, that's inspiring and cool, but like everything's already been done. And the stuff that hasn't been done, like I'm not gonna be able to, like that's the kind of stuff that's left for like the top people in the field, right? The super experts. I'm not gonna be able to solve those problems. There are solvable problems in this space because just not a lot of people are experimenting with it. And it's not only like a fun, quirky side thing, it like can have a real impact on the user experience. We get a lot of like really nice testimonials from users about our confetti because it's fun. So yeah, come help work on it. That's it. I'm Josh. As alluded to, any questions? Cool. Oh, yes, go ahead.
Was confetti your first like whimsical addition?
I think so, depending on, I mean, so we've added like cute little illustrations, but those are really just embedding images. Yeah, we're also adding sparkles right now, which is like very similar, but yeah. So there's others, but yeah. Thanks. Yes. That's right. And it sounds, yeah. Well, so it depends, right? Like if I wouldn't do this on a component that it's at the top of the tree, because whenever you render your top level app component, like that actually takes a non-trivial amount of time. But the size of your tree really makes a difference. So the canvas component, or sorry, the confetti component only has one child, the canvas, and it doesn't actually take that long. That said, we actually don't do it this way at Khan Academy because we noticed it's like a 5% difference. Which in this case just translates into us not being able to have as much confetti. So we actually did move to just having an instance variables on it, and then we just call force update whenever it changes as a way around that. But the state really, I'm always surprised by how quick running the state updates are when you don't have a complicated tree. Like I often use peer component, which some people may have heard of, which essentially does a shallow compare on the props. If you have a lot of props and a shallow tree, the shallow compare is actually more expensive than the virtual DOM recomputation. And shallow compares are really cheap. So React updates in production. In development, it's slow because it does all kinds of stuff. But in production, like rendering based on the state is not as impractical as it might sound. Yes?
I noticed they're all finished components isolated with a nice API and access them. Do you ever use higher order components to sort of isolate that thing and actually just give a bit of the behavior of some components and then send it?
Right. So you can totally do it that way. I'm partial to the render props API, which does kind of the same thing, where let's go back and actually look at something way back in time. I need sound effects. Right, so this is like the render props API, where node consumer renders a child, but the child is just a function, and that function is given data. So node consumer doesn't control any DOM, in the same way that a higher order component doesn't control any DOM, or it can, but we're kind of using it, like you can imagine node consumer as a higher order component around somewhere else, and it would have kind of the same effect. So yeah, we totally could do it that way. I prefer this way, not for any good reason. I guess the reason I like it is that all of the logic is visible right at the call site. So if this was a higher order component, it would not be clear where nodes was coming from. It would just be like a prop magically injected into somewhere else. You wouldn't actually see that transfer of data. Whereas this way, like it's right there when you're looking at how the component's rendered. Anyone else? Going once, going twice. I need the auctioneer voice that I don't have. All right, well, thank you. This was fun.